Alright, 6th grade, this is math lesson 92, and this lesson is about exponents found in 3 different ways: expanded notation, order of operations, and in fractions. You'll notice that I took the time to write out the chart. This is also in your math lesson in the facts box. But basically this is place value, the first family, ones, tens, hundreds, that's the units. The second family to the left, 1,000, 10,000, 100,000, so the thousands family. And then the millions family, followed by the billions and trillions. Of course, we know each family goes from right to left, ones, tens, hundreds, and then simply starts to tack on the family name. The reason that I wanted to draw this out is because also, on top of knowing your place value, which hopefully you should be very familiar with already, when we look at the ones place value, when we look at exponents, that's known as 10 to the 0 power. When we look at the tens, that's 10 to the 1 power. The hundreds place is 10 to the 2nd power, or 10 squared. The 1,000s place is 10 to the 3rd power. The 10,000s is 10 to the 4th, and you can see it goes on, so on and so forth from there. So really make sure that you know, along with the place values, what exponent is what exponent goes along with that particular place value. So this is something you might need to be going back to just to think about until you get familiar with it, and you can do it without having to go back to look at it, and just you can do it in your mind. Alright, but nonetheless, so that is going to be a valuable chart for us with this lesson. Now, getting into a couple things, if you remember a while ago we talked about standard notation versus expanded notation. So standard notation, this is what we're used to, which is why it's called standard notation. The number 365 looks like this. In expanded form, it looks like this. Since 3 is in the hundreds place, we go 3 times 100 in parentheses, plus 6 is in the tens place, so we say 6 times 10, and then 5 is in the ones place, so we put it in parentheses and we write 5 times 1. So standard notation versus expanded notation. Now when we get into the examples, this is where that information will come into play. So the first example there, it says write 186,000 in expanded notation using exponents. So it's simple enough when we do the expanded notation if we're going to do it like this, but we want to turn those zeros into exponent form. Okay, so the easiest way that I like to think about it is, we know the ones is 10 to the 0, the tens place is 10 to the 1, 10 to the 1st power, the hundreds place is 10 to the 2, the 1,000s is 10 to the 3, 10 to the 4, 10 to the 5. Okay. Another way you can think about it, just if you look at the expanded notation, there are 2 zeros, so that's 10 to the 2, 1 0, 10 to the 1, no zeros, so 10 to the 0 power. Alright, but nonetheless, as we said, 0, 1, 2, 3, 4, 5. So we're going to go 1 times 10 to the 5th power. Close the parentheses, write the addition sign, and now we've got in the 10,000s, that's 8, so that's 8 times 10 to the 1, 2, 3, 4, 0, 1, 2, 3, 4. 10 to the 4th power, I should have put that inside my parentheses. Plus, and then the last number we have is 6, so 6 times 10 to the 0, 1, 2, 3rd power. And that would basically be our expanded notation using exponents there. Alright, and then we get into order of operations, and we'll notice that there are exponents in there as well. Remember, the order of operations is PEMDAS. I didn't write this down on here, but it is in your book. Remember, PEMDAS stands for parentheses, exponents, multiplication, division, addition, and subtraction. I like what the book said. They gave a little acronym to kind of help you remember PEMDAS. Something to the effect of, please excuse my dear Aunt Sally. So there's something extra for you to help remember it if you don't already just remember, if you don't automatically just remember PEMDAS. But nonetheless, of course we look and see if anything is in parentheses or if anything is in exponents, and we do those first. Okay, so as we look here, we see that 3 to the second power is parentheses, or excuse me, exponents, and then we've got parentheses here. So we can solve this. Hopefully you remember 3 squared means 3 times 3. So 3 times 3 equals 9. And then we solve what's in the parentheses here, 8 plus 8, 16. And since we didn't solve anything else, we're going to start bringing those things down. So we bring the 5 and the addition sign, multiplication sign 2, subtraction, we solved that already. Division sign, we could actually solve this one right now. The square root, we're going to stick that in there with exponents, parentheses and exponents. The square root of 16, if you remember from that lesson, what number times what number equals 16? And we know that it's 4 times 4, so the square root of 16 is simply 4. Alright, so now we look at the second row. And remember, when we work order of operations, we always want to work it in the upside down pyramid form. Alright, so we're looking here, we did parentheses, and we did exponents. The next set is multiplication and division. So we look to see, is there anything that we can multiply? Here, 9 times 2 is 18, so we bring that down. Let me clear this up. And we've got 16 divided by 4. 16 divided by 4 is 4. Okay, so the only things we've got left, and I guess you can draw so that you see what you're doing here. Okay, so we see that we haven't used the 5 plus, so we'll bring that down. We haven't used the subtraction sign. Alright, so we're left with addition and subtraction, so we can go left to right. 18 plus 5. Okay, you guessed it. 23. And then subtracted by 4. So 23 minus 4, we know is 19. Final answer. Circle or box that, and notice the form of what it looks like. It's not perfect, but we want it to look like an upside down pyramid. Alright, so we continue on. Now we're going to see fractions with exponents, different examples here. Don't let that scare you. Remember, all an exponent means is we multiply the base number as many times as the exponent says. So if we see 2/3 in parentheses and it's cubed, it simply means 2/3 times 2/3 times 2/3. Okay? So I don't have room here, but the best way to do it is one at a time. This is not 2 3 times, which equals 6. It's 2 times 2. So if we go 2 times 2, that's 4. 4 times 2, that's 8. This is not 3 times 3, it's 3 times 3, which is 9. 9 times 3 is 27. And then we check, of course, every time we get fractions, look to see if we can reduce. Looks like the greatest common factor between 8 and 27 is 1. So we're done. We circle or box our final answer there. Alright, so we've got an expanded notation question here. It says write 2,500,000 in expanded notation with exponents. Remember, it's easiest, the way that I like to do it, is the ones place is 10 to the 0. So that's 0, 10 to the 1, 10 to the 2, 10 to the 3, 10 to the 4, 10 to the 5, 10 to the 6. Okay? And so you can always go back and look at your chart here if you need to, but that's 0, 1, 2, 3, 4, 5, and 6. 0, 1, 2, 3, 4, 5, 6. So we're going to go 2 times 10 to the 6th power plus 5 is the only whole number we have left. The other ones are zeros, so don't need to do that. So this is 5 and this is 1, 0, 1, 2, 3, 4, 5. So that's 5 times 10 to the 5th power. And that's our final answer there. So we circle or box the final answer. Alright, we go to practice problem E. It says write this in standard notation. Now this is backwards, so you're going to kind of have to think about it. We're used to doing it this way, but we can simply write the 5 and the 2 next to each other. That's easy. Okay, but since this is 9, We start with 0, 1, 2, 3, 4, 5, 6, 7, hey, that worked out, right? 8, and 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then we start to just fill in our commas and put those in where they're supposed to go. There we go. Okay, letter F, we're doing some order of operations here. So 10 times 2 to the third power times 3 minus, open parentheses, 7 plus 2, close parentheses, divided by the square root of 9. We're looking first of all for the parentheses and exponents. Okay, so I can see some exponents here, square root, and I see parentheses. Let's do parentheses first. 7 plus 2, of course, is 9. So we'll bring that down. We can keep the parentheses if you'd like. 2 to the third power is not 2 times 3. Remember, it's 2 times 2 times 2. So 2 times 2 is 4. 4 times 2 is 8. And then the square root of 9, what number times itself equals 9? We know that that's 3, because 3 times 3 equals 9. And then we simply bring down everything we have not used. So 10 plus, we didn't use the multiplication, and the 3, we didn't use the subtraction, we didn't use the division symbol. And now we're looking for the, so PEMDAS, that was parentheses and exponents, we're looking for division and multiplication next. Okay, so I see a multiplication here and a division here. 8 times 3 is going to give me 24. 9 divided by 3 is going to give me 3. Okay, so I bring down what I didn't use, which is the 10 and the addition sign, and the subtraction. And then of course I've got addition and subtraction left, so this simply means 10 plus 24. Hopefully you can do that in your head. We know that that's, if you want to do it slowly, that's fine too. We can just write it here and then bring that down. 34 minus 3, of course we know is 31. There's our final answer. Alright, this one might be a little easier. This is 1.5 times 1.5. Looks like we're running out of space down there. Let me move this up. And that simply means 1.5 times 1.5. I'm not going to take the time to work this out. I think you guys are pretty sharp enough to be able to figure that out. Same thing here. I'm not going to work this out. I'm just going to show you what it looks like. Don't try to do that in your head though, because notice that that is a decimal. So you'll actually want to write that out. The big problem we forget is remembering, keeping track how many digits after the decimal point. That's 1. That's 1. So my final answer should have 2 digits after the decimal point. And then from there, I know you guys are going to be able to handle working the problems out from there. So just a couple reminders on that. Alright, so that is the lesson regarding exponents.